Okay, so hello, my name is Billy Marshall, and today we are going to be covering some fluid simulation basics in Houdini 17.5. So, the two types of particle fluids we are going to be covering today are flip fluids, and we're going to be covering the flip tank effect and the emit particle fluids effect. The emit particle fluids effect is going to include colliders and sort of interacting with objects, and we'll show you how to set up each of the two, and we might also move some objects through the flip tank fluid. And possibly at the end of the tutorial we'll cover some small basics on whitewater simulation, but for now let's just get started on working with emit particle fluids, shall we? So first things first, I'm just going to make a ground plane. This can be hidden later, but we're just going to have this as a base layer to work from, so that we have something the water can initially collide with. Quick shortcut you can use to zoom out to your whole scene is if you press space and H at the same time. You will zoom out to show everything in the scene from the default view. This works on both Mac and PC. As you see, I'm operating on a PC, but this is a universal shortcut. So we've got our ground plane in the scene here, which we've got here, and we're just going to name it floor, just for easy purposes. Go in there, you just see it's an import ground plane. So this brings up a DOP network. So the DOP network is where all the simulations is going to happen. So here we've got the ground plane one, which is obviously you've seen, and here we can change the grid size and the scale. We've got merge, we've got a static solver, merge again, and the gravity tool. So the gravity tool is something we will be using, but that's due to the fluids and not effect. It doesn't matter with this. The flip fluids will all go into the dot network. So we're going to start with the emit particle fluids, so this one. So firstly we need an object to emit from. So for this example we're just going to use a little box, and we're just going to put it above here for now, just to show sort of the basic concept of what's going on. So we're going to rename this to emitter, and if you press L on the keyboard it will lay out everything as it is. It's again universal shortcut. So I'm just going to put my geometry over there in its own tab. So if you use this, it makes groups. We're just going to put this in the tab for colliders. Obviously we've got floor colliders. I'm just going to change the colour of that to black. And disable that again. Keep that down there, and that's my emitter. So once you've got your emitter selected, you want to click emit particle fluid and give Houdini a bit of time to calculate what's going on. We don't want it to emit into anything right now, which is another setting I'll go over a different day, but for now just click enter, because that's all we want, because it's going to collide with the ground plane anyway. And now, if you'll notice, let's just change the camera. Also, if you hit space H to change the camera back to the default view, it'll revert all the settings of moving around in the viewport back to basics, so it makes it easier to move around, zoom in and out and stuff. So as we can see here, it's taken us straight into our dot network. We've got then two more sets of nodes for the fluid simulation. So we've got the particle fluid, which is a useful node, and the particle fluid interior, which we will not be touching or messing around with. So we can just put that over there and leave that alone. I'm going to leave that enabled, but we'll just leave that alone. So if we disable the emitter, if you turn it off at the viewport, it'll still be there, but you just can't see it. So for now we're just going to turn it back on, and we're just going to play and see what happens. So the water should just fall down and then collide with the ground plane, which is exactly what's happening. So obviously you can see on my screen it's starting to take a lot more time. It's because just the amount of particles interacting with an object is increasing. So obviously there's a big splash on the ground plane. So whenever we make changes, make sure you go back to frame 1, because if you have the slider on any other frame except for one, any changes you make, it's then got to simulate from frame 1 to that frame before you can load it. So we're going to move the emitter object, I believe, to the center, just because it's easier. And if we put that back over there, yeah, okay, so I'm just going to raise that up again, put it on like 5, let's make it 7. Okay, so there we go, got the emitter, and again, works the same as it did before, just moves its place, you've got the particles coming out, and then they obviously splash and emit on the ground. So, once you sim all this out, it's not going to look like little dots representing the particles, it's going to look like other stuff, which we'll get onto. But first, let's talk about areas of the dot network and what's actually important to control and what's making this work. So, here, you've got the source, okay? Now, the only interesting setting I like to play around with in the source tab is the activation. So the activation controls basically if the source object is emitting. So if it's set to 1, it'll emit. So let's make a keyframe for it, for example. So Alt left mouse click will make a keyframe. Let's drag it to frame 1. As you see, as I said, it's got a cook from that, so there you go. If I Alt left mouse click again, and then change that to 0, you notice that it changes in the activation tab. It's now 0, so I'll show you how that works. So here we go, it plays for a little bit, drops that like that, it emits for a second and then completely stops. So you've got a nice sort of splash, possibly something like a quick bit of water from the tap, or something like that, so you turn it off, and then it does that. So we're just going to delete the channels for that, because we always want it to emit for this. Let's just get rid of that. Let's cover the other important objects. So the merge is just merging that in, so it's got the activation thing in there, which we control in here, so there's no worries about that. Let's change that back to 1 before I forget. So we're going into flip fluid object. This is one of the two key parts of the water simulation. So in here we have the particle separation tab. Now, particle separation controls basically how many particles you have in the scene. So the more particles you have, the more water there's going to be, but in turn that's going to be the more sort of simulation that needs to be done. So as we can see, we've got it to set to 0.1, which is just the basic. If I set it to like 0.07, you notice now there's already a lot more particles in here compared to that. So let's just redo that. So if I play this out again, there's going to be a lot more particles interacting in the scene. It's going to take a lot longer because there's many more particles, but I'll show you just how it looks. So as you can see, there's more detail, there's more water, it's more of a constant flow instead of like bits. And this is sort of something you want to try and achieve. Like, it looks a lot better, you can just tell from the simulation itself. Just getting a nice sort of clearer ring going outside. To be honest, that looks nice. We've not even done anything yet, really. All we've changed is the particle separation. So for this tutorial example, I'm just going to put it on 0.09, just to, let's put it on 0.8. Keep it on 7. Just, I'm not going to make it any smaller, which you can. But that's just to sort of save a render time and improve the speed and quality of the video. So I don't have to keep pausing it and stopping it. So, moving on, you noticed I've moved into the flip solver. The flip solver is the other key element of the water simulation that you'll be using. So you want to go into the volume motion tab in here and go on to collisions. So what this is the velocity scale is the key element you need here. So the velocity scale basically means that it controls the amounts of water reacts to things. So like when we saw it drop down and splash before, if I up the velocity scale, the water will splash and react more. So for example, let's set it to 10, okay? Obviously this goes above 10, it's just showing the max of the slider, but it can go to what you want. The higher you have this, the better the effect's going to look, but it increases render time again. But as you can see, there's more reactions in the water, making it look more realistic. So one of the many balances you're going to need to get is the particle separation with the velocity scale. Obviously, I'm not out here trying to make anything specific, I'm just trying to show you how it looks with some colliding objects and sort of controlling how good the reaction of it looks. So compared to last time, as you can see, there's a lot more essential like waves and stuff splashing from down. It looks a lot nicer. So I'm going to set this to 15. Made a rookie mistake, like I said. Don't ever stop it there. If you don't want it to simulate something, you can just hit escape and go back to frame 1 and then it can start simulating again. So cool. Before we move on to anything else, I'm going to add a little collider in and show you how to do that, just so the water has something to connect with. So as you can see, I just spawned in another cube that I just hit enter once I click the object, which will spawn it in sort of the world neutral. So I'm just going to make a bit of a rectangle here for the water to flow down, and that's fine. So we're going to call that air collider, because that's exactly what it is, and then we're going to put that in my colliders tab. So to make this a collider, you go into collisions, make sure you've got that selected, which we do. I'm just going to go back onto that key, and then you click static object, and I believe that's done. So it's as simple as that to make it a collider. Now, in theory, the water should collide with this object when it's going down. So you notice the simulation is taking longer now, because it already has something to collide with. So I'm going to pause that. There's a few things I want to talk about here. So, as you notice, the object itself has got the water colliding with it, but you can also see that inside the object, the water is going through. So you're going to think this is a problem, because obviously if you're making a collider, you don't want the water to just go straight through it. So if you click back into your dot network and go into your new collider, so this is the one we want. We're going to the collisions tab, okay? So firstly you want to whip up the wireframe of the objects, okay? So this is all the stuff in the object. And then you want to change the division size, and the offset surface. Basically, we want to control the sort of mold of the bounding area of the box, so that it's more precise. So if we set this to 0.01, for example, and go back, and then start messing with the offset surface. Let's make that 2. I don't think we overly need to mess with the offset surface just because it's a basic cube, but decreasing the division size should make it so that there's more voxels for the water to react with. So let's whip it back on smooth shaded, go back to the object level, and then hit play again, and let's see if the collisions work better. So as you can see now that I've changed the voxel size, there's no water colliding in the box. So it's just because the box's voxel size wasn't detailed enough that the water went straight through it. With more complicated objects, as I mentioned, the offset surface, you'll be able to see, here we go, this is why we couldn't see it. If you go back onto wireframe now, and you turn the collision guide on, do you notice how all of this area is now blue? Okay? So before, it was only set to 0.01. Let's go back to frame 1 before we start doing any changes. Do you see how less the detail is? So that's supposed to be a rectangle object, but that's how its internal collisions work. So by decreasing this, we make it more detailed, and it looks how it's supposed to be. So now everything will sit there and collide with the object, just like I showed before. So that's all good. We've covered that, we know how that works. So now you sat there thinking, okay, well I've got the particle size, I've got that high one, and I'm okay with the collisions and how that looks. I want it to actually look like water. So let's just turn the emitter off, shall we, for now. And this is where the particle fluids tab comes into play. So here you have the display flag automatically set to DOP import. But the real hero of this section is the particle fluid surface. So let's set a display flag for there. And as you can notice now, it looks like a weird cube of water. This is actually the surface texture of the water and how detailed it's going to look. So, a few things to cover here. If you notice, we also have a particle separation tab. This is directly linked with the other one. So you can control the particle separation from here, but what you'd want to do is delete the channels from here, so then you can then change it. But for now, I'm not going to do that, because I think it's fine. So if we go into the voxel scale tab, here it will control how detailed the animation looks. So obviously, you already know that. We've been through that before, it's the same thing again. I believe if we go back over here, I can't remember what we set our voxel scale to. Oh, never mind, we were talking about velocity scale before. So the voxel scale is how detailed the animation is going to look. So the lower the voxel scale is, the more detailed it's going to look. So we'll set it to 0.5. Okay. Then we have the influence scale. So this smooths out the water texture itself. Okay. 3 is probably going to make the water scale look a bit rugged, so we're going to set it to 5. But you have to come to a sort of conclusion of how smooth you want the water, because the smoother you have the water, the more detail of the water gets cut out because it's smoothing off the edges. So, for example, I'm going to leave it on 3 just to show you how it looks. Because we've got a display flag checked here, and I play it, it's going to take a lot longer, but it's going to flow or look like water. So I'm just going to let it play out for you here. As you see, it's emitting like it was before. It kind of looks like goop right now, but that's just because it's obviously rendering it out. But as you can see here, it's splashing, and this is where it looks like real water. So there's a few sort of factors controlling this. So obviously we've got the influence scale, which is controlling the smoothing. So I am going to do what I said don't do, but I'm going to up this here, and this will have to re-cook it out. But you see that, how it's now a lot smoother. Now it does look like goop. Set it to 4. It's kind of looking like water. I think I might just keep it on 3 for this example. But you notice the edges are a lot more rugged. You know, maybe we will put it on 4. See, that was all sort of angled and sort of sharp, and now it's all smoothed off. So that's what we want. So we've got the particle separation, again, controlling how much water has been spawned, and the voxel scale. So let's turn the voxel scale down. Give it a moment. Like I said, this is calculating sort of the detail. So you can't see it very well, but that has changed the detail, and it will make the simulation go a bit slower, but it looks more detailed now. So as you can see, before it was a lot faster, because now it's more detailed, it's taking a lot longer. So I'm just going to turn my voxel scale back to 0.7, just so I can show you how the animation looks. Gonna have to hit our trusty escape key, I think, to stop this from simming. There you go. Don't worry when it does this, it's just because you've cancelled the simulation at that point. It'll start, see it's back, no worries at all. So let's play it out again, get a bit more cash with the sim. We'll get it so it interacts with the floor, but you can notice how it's now a lot faster. The balance is controlling the voxel scale and influence scale in this part, because you want it to look smooth and detailed, but you also don't want it to take absolutely ages. So you've got to find a key to your project that you think is nice and works well. So right now, like I said before, it kind of looks like a bit goopy water, but that's just because of, you basically think of this as like putting a tap on a spoon. If we check this, it plays it back in real time. So we'll play these 37 frames in real time, so about a second of animation. I think it's being a bit slow because of the sort of caching and the simulation itself, but at least it's not absolutely rapid. But there you go, we've got a nice splash animation colliding with an object. So a few more things before we talk about the other sections. Once you're all happy with your how your animation looks with it colliding with an object, sort of thing, you have two caches here. Now, once you're happy with everything, you're going to want to cache these out. So make sure you have this file extension, so we're going to Command X that, find somewhere you want to save it, blah blah blah, I'm not actually going to cache it out, but you will need to. Find somewhere you want to save it, give it a name, put this file extension on it, and then save to disk. Now this will make a file cache where it will render out each individual frame for the actual sort of height geometry, so you can notice it's all in blocks. So you want that to be rendered out by the cache. And once you've done that, you can then click load from disk, and it will no longer have to cache on the system and won't take nearly as long. So once you've got all your animations perfect and spot on, you want to cache it out. Then you want to do the same thing for the surface cache, which is how it actually looks. So make another folder where you've made the first one, give it a different name, make sure you have the file extension on, save to disk. Once it's all done, load from disk, and the animation should be smooth and shouldn't lag, because you've already got it all saved out. Make sure you check the load from disk. It will load it from your save file, I won't have to keep simulating it out, so it'll run smooth in your scene. So now this is the basics of basically fluid simulation. I'm gonna talk to you now about applying them to the flip tank object. Both sort of work in a similar way, but I'll be back in a second to discuss that.